Hi everyone. So you've decided that you want to hack a window AC unit. Well, me too. I want to hack my window AC unit because I'm building a wine cellar, and these window AC units, they don't let you go below 60 degrees normally. So you have to hack them. And I'm sure you've watched lots of videos online about people hacking their AC units and lots of different ways to do it. Maybe you're building a wine cellar. Maybe you want to build a walk-in cooler. Maybe you're a florist and you want a cool place for your flowers, or you need to build a meat locker, or I don't know. Maybe you just want to hook up a wall thermostat to a normal window air conditioning unit in your home. That could be another reason. And so like I said, you've been looking all over the internet trying to figure out how other people are doing it. You may have watched people using a device called a CoolBot, which is cool. You may have seen people using other things that they've gotten on Amazon, like aquarium heaters, or maybe they've tried to wrap the thermostat on the air conditioning unit with a light bulb to keep it warm. There's all sorts of ways out there. Well, I've watched them all too, and some of them I find complicated. And so I spent some time trying to figure out what is a simple way to hack your air conditioning unit. Simple wiring, where you have the least amount of stripping new wires and all this kind of stuff that you see. And also I wanted to hook mine up to a smart thermostat, and a lot of thermostats you buy today are smart thermostats. They've even got color LCD panels on them, and you can hook them up to Wi-Fi and control them with your phone. And I thought that would be pretty cool too. And you're still talking about something that's a lot less money than, than purchasing a wine cellar cooler, where you're going to spend, I don't know, $1,000, $1,500. So if you get like this size that I have here, I think I got it used on Amazon maybe for $80. Though I did want to get a nice thermostat, because I do plan on using it for an additional feature, which I will put into a different video. But for this video, I just want to concentrate on the air conditioning unit itself and get that set up. So before we start wiring it up, let's take a look at the schematic. Here are all the components that you'll need to build out this system. We have a wall thermostat, a 24-volt transformer to power the wall thermostat, an outlet to power the air conditioning unit, an air conditioning unit, and within the air conditioning unit, where I have the two clouds, you'll need two relays. Let's go into more detail, starting with our thermostat. So I'm going to use a smart thermostat for my setup, but as long as the thermostat that you've chosen can do everything that I describe in this schematic, use whichever thermostat you like. On the thermostat, you'll see that I'm using 4 terminals for this. First one is the Y1 terminal. Y1 is typically used for your first stage cooling. And this Y1, if we follow that yellow line over, my yellow 24-volt line, it connects to the compressor relay. This compressor relay is going to replace the air conditioning's knob thermostat. We'll talk about that more in a few minutes. And then you can also see that the common wire is connected to the other spade terminal. The next terminal on the wall thermostat is G. G controls the fan. And in my case, it not only controls the fan, but it controls the entire air conditioning unit. It prevents power from getting to the air conditioning unit if it's not energized. Next is R. R is the power source for the thermostat, and that connects to the 24-volt transformer. And then C. C stands for common. This is your common wire. Think of it as your neutral wire if you're familiar with the wiring in your house. This provides the circuit to complete. So without it, even if you energized Y1, for example, oops, I have it marked as Y2 over here. Even if you have it that energized, without the C, nothing would happen. The relay wouldn't do anything. So that's the thermostat, 24-volt transformer. This is typically what you would use for like a doorbell. I'm using the doorbell style transformer. Let's take a closer look at the air conditioning unit now. So this air conditioning unit, I tried to make this wiring as simple as possible. I went through iteration after iteration and finally settled on this one. This has the least amount of work. You don't have to do a lot of wire stripping. Some of the videos you may have seen, they're stripping wires and disconnecting everything. The reason I like this one is because it has there's only one wire that you have to create for this. And the rest you just unplug from where they're currently plugged into and plug them into the relays. So let's talk about that a little more. Let's start with the fan relay. So the fan relay, when G is energized from the thermostat, it energizes the magnetic coil, and the two spade terminals at the top of this relay, that's where the power to the air conditioning unit is turned on. So when G is energized, those two spade terminals at the top, they connect. There's a little, switch in there that switches them on, and it allows power to go from the left side to the right side and provides power to the air conditioning unit. The two spade terminals below that are normally closed. So if there was no power on G, if G wasn't getting energized, then those would be closed. And so the switch just flips up, and when G gets power, the two in the middle, they turn off, and the two on the top turns on or close. And you may have watched videos where the knob, the main control knob on the air conditioning unit, they removed it. It's no longer usable or whatever. In this diagram, I have left it usable. You could still use this knob as like a master control knob. You can turn off the air conditioning unit if you want, and then the thermostat's not going to do anything. You can turn it to low speed fan, high speed fan, which I think is pretty cool because, you may get everything wired up and you've only connected it to high speed, and then you realize, oh, that's just way too loud. It's way too much fan. I don't need all that. And this allows you to continue to use that knob to turn up and down your fan. And so, like I said before, the cloud is the only places where you need to make changes. So the wire that you see there that's connected to the left side of the fan relay, that was connected to the on-off switch. At least it was in my air conditioning unit. And I'm using just a basic off-the-shelf 5,000 BTU air conditioning unit. I would call it an analog air conditioning unit. I'm not using the digital kind because I didn't really want to mess with that at all. So you take that wire off of the backside of the on-off knob and you plug it into the left side of the fan relay. And then you'll need to make a pigtail, just a little wire with some spade connectors on each end, and plug it into the other side of that relay. And then plug it into where you just unplugged the previous hot wire and plug it in there. Now you have your connection again, and it'll just interrupt it when like I said, when the G terminal's not energized. Then we have the compressor relay. The compressor relay is energized, and here it says Y2, but I really mean Y1. That's a little typo there. When Y1 is energized, it will energize the compressor relay, it will make that connection across the top two spade terminals, and it'll turn your compressor on. And you can see the cloud here. The only changes you need to make inside your air conditioning unit are to remove the air conditioner's thermostat knob and replace it with this relay. That's it. You're just unplugging. In my case, those are red wires that are plugged into that thermostat. You unplug the red wires from the thermostat and you plug them into the relay on the normally open spade terminals at the top of the relay. You don't have to unplug the red wire from your on-off knob. You don't have to unplug it from the compressor. Leave everything else alone. The fan, capacitor, don't mess with any of the wires connected into those. Assuming that, like I said, assuming that you're using just a standard off-the-shelf air conditioning unit that looks like mine does, that looks like this diagram does. And you can use this to trace all the wire. Once you get your air conditioning unit opened up, you can trace all your wires and make sure that it matches this diagram. That's what I did. I traced all the wires in my air conditioning unit, and that's how I came up with this diagram. You should also find a little diagram inside the air conditioning unit. Once you get it opened up, it'll be stuck to the styrofoam or the inside of the panel. Because the compressor relay gets its power from the on-off knob, and the on-off knob gets its power from the fan relay, the compressor can never turn on without the fan being turned on. It's daisy chained. However, the fan can turn on without the compressor turned on. And that's important because you may have watched other, videos online about people hacking their air conditioning units, and it looks really cool and all until you read the comments and they mention, well, this thing got so cold that it froze up the coils. And the idea here is that you can keep the fan running after the compressor turns off to run the ambient air temperature through those coils and warm them up just a little bit so they don't freeze up. That is an important feature to have. So make sure that your wall thermostat has the ability to delay the fan from turning off. Here are some shots of the parts I used. Here's the transformer. It's a 24 volt 40 VA transformer. It's a front view. You can see the R terminal and the C terminal. Those connect to your thermostat. And then here it is hooked up. Here is a close-up of the relay that I'm using for the blower and for my AC unit. Down here at the bottom, we have connections for, let's say 1 and 3. You can see those numbers there. That's the 24 volt connections. This is to connect from the thermostat. So 2 and 4 are normally open. That means there's no connection between them. So if this isn't fired up here down between 1 and 3, 2 and 4, there's no connection between them. So you can see 2 and 4 are normally open, and 5 and 6 normally closed, and 1 and 3, it switches these guys to opposite of what they are. The first thing we want to do is we want to take our 2 relays here and put them inside this electrical compartment and attach them to the back wall. But as you may have watched in other videos, you don't want to drill through the back wall because you're going to hit some stuff that you don't want to hit. So let's take this out before we do that. And there's just a couple screws here. Okay, so I've attached my relays to the back here. You can see them. And I took this thing off so to make sure that it doesn't touch any of these. So we're looking good there. Yeah, you definitely don't want to drill holes through this thing with this on. Take it off. So now we just need to hook these up. So this is going to be what I'm calling the fan relay, and this one will be the compressor relay. This one is going to replace the thermostat from that used to be here on the front. That was the thermostat knob. So here's my extension, my power cord. So let's take the black wire off of that, which attaches right to there. So we'll pull that off, and that is going to go to the fan relay on one of the terminals. I can get that on there. There we go. And then I made this little pigtail. I put a little solder in there too, just so it doesn't come loose. We're going to connect that where we just took that wire off of the master switch. So put this one on there. On the other side of the relay. And then we'll plug this one into where we pulled the last one out of, which goes right there. Okay, now we've got the power coming in, and it's going to go through the relay now instead of directly to the switch. That allows us to still use the switch and switch between all these settings if we want to. And the thermostat, the wall thermostat's going to control it. Next, we're going to replace the AC thermostat with this compressor relay. All this does is turn on and off the compressor. So you can see here I've already labeled it too. So let's take these off. And attach them to the compressor relay. Set this down here. There we go. Now that's all that's left in here is to hook up our 24 volt wires from the thermostat. Okay, thermostat wires to these relays temporarily. So don't do this. Make sure you put the spade connectors on them just like we did with the 120 volt wires on the other side of the relay. So put all your spade connectors on and hook them up like this. So you can see here the green wire Well, ignore that green wire there. It's just using it. I'm just using that as a jumper. So this green wire though connects to, on my thermostat, it's G. It's the fan terminal on your thermostat. So this is going to energize the fan. So when this contact here is energized, it flips the relay switch and sends power across these two here. And when those connect, as long as your knob is turned on somewhere, the fan turns on. The fan, there it is, the fan. And then the next one is your common, and all your commons need to connect to each other. And typically it's blue. I'm just using the white wire. There's my blue wire. Should have used the blue wire, but I'm using white. And so there's my commons. Then this yellow wire, if you're setting it up with if you're only connecting a one cooling unit to your thermostat, then you typically use a yellow wire and connect that to the Y1 terminal on your thermostat. And then when this gets energized, when your thermostat calls for cool, it will energize this. And that, since we've replaced the thermostat here, we're now using the wall thermostat, this will tell the compressor to turn on. On your thermostat, and here's my thermostat, find the setting where that's called like fan delay, something like that, fan off delay. Select the number of seconds the fan will run after the compressor turns off. Right, so I have mine currently set to 30 seconds. So what that'll do is the thermostat will call for cool, and the compressor and the fan will turn on at the same time. And as soon as the room is cold enough, the compressor shuts off. Oops, I lost a wire there. And the fan will keep running for however long you tell it to in that setting. Let's see if it works. I will adjust the cool to temperature down below my room temperature. There we go. It's firing up. The little fan is spinning. It says it's cooling. It sounds like the fan is going and the compressor's running. Let me now warm it back up, and the fan should keep going and the compressor should turn off. Yep, compressor turned off. The fan is going. So the fan's going to continue for 30 seconds. The compressor is no longer running, so these coils are no longer getting the cold juice running through them. So now the ambient air in the room, which is probably, for me it's going to be 56 degrees, which is the ideal temperature for a wine cellar. There it goes, 30 seconds is up. Air runs through and it warms those coils up a little bit. If you'd like a list of all the parts that I used in this video, you can find it in the description section on YouTube. If you plan to purchase any of these for your own project, maybe it's a wine cellar like mine, please start from there. Then it's a win-win for both of us. Well, there you go. I hope you all enjoyed my show and tell of how to connect a thermostat to a window air conditioning unit. The benefits I tried to show you were simple wiring compared to other videos you may have seen, the continued ability to use the on-off, fan high, fan low turn dial, the fan on-off delay feature, so hopefully it won't freeze up. That's the goal. And if you go with the smart thermostat, like I am, you can connect it to your phone. You can check the temperature while you're on vacation. And this thermostat even has humidity controls in it. So you could add a humidifier if you notice that the humidity levels are too low for your wine or your cheese or your broccoli or your deer, right? Thank you and happy building. And you know what? Here's to drinking old wine when you're old.